Okay, we're going to look at a z-score today. So a z-score is how about we're looking at a bell curve and you don't land exactly on one of the boundaries. In other words, the normal distributed bell curve I gave you yesterday had the markings of every half standard deviation above average or below average. What happens if you're not right on one of those marks? Well, that's called a z-score. So a z-score is simply this. It's how far you are away from average. So let's say this is you right here. You scored something. Well, what we do is we take your score and we subtract it from the average. And then we simply divide by the standard deviation. And that, people, is called a z-score. It's very easy to do. So let's look down here at an example. We went out to the 7th grade and we surveyed the boys' heights. And again, here's that key phrase that we always look for. We found that the heights are normally distributed, which means they make a bell curve. Awesome. We have a mean height of 62 inches and a standard deviation of 3.2. So, you know me, I always go and draw a bell curve. I like to see it visually. So I came down here and I put my average at 62, whether you want to say that's x bar, or if you want to call it mu, whatever. And then I gave myself 3 standard deviations to the right, and likewise 3 standard deviations to the left. So here's a kid of 66. 66 is right about there. We can see that it's not exactly on a half. It's certainly 1 standard deviation above, but 1 and how much more? Well, this is what we do. We take the piece of data we're looking at, 66. We subtract it from the average, and then we divide it by 3.2, because that's the standard deviation. 4 divided by 3.2. If you do 4 divided by 3.2, I believe it's 1.25. Quick check on my calculator, and it is. So this kid who is 66 inches is a full standard deviation and a quarter more above average. All right, so now we got a little shorter kid here, 57 inches. So how does 57 compare to the average, which is 62, and divided by the standard deviation? Well, 57 minus 62 is negative 5, divided by 3.2, and now the negative is telling us something. The negative is telling us that we're below average, and we get negative 1.565. So that means he is a full 1.5 and a smidge bit more below average. And I think it's pretty easy to see now. We got this kid right here, he's pretty tall. He's 70 minus 66. Oops, sorry, not 66. Not bad. 62 divided by 3.2. We can see that this kid is really towering, probably a volleyball, basketball player. He is a full 2.5 above average. So it's pretty much what we were doing the other day. We just now can look anywhere in the bell curve because now we can find precise points. We have more information than just the half points. So on a standardized test that are, once again, there's that word, normally distributed, so we know it's a bell curve, draw ourselves a bell curve with a mean of 560 and a standard deviation of 75. All right, so we take our time and we get that drawn out. Find the probability. Okay, that's a key word, probability, so we know it's part over total, that a test picked at random would have a score larger than 720. So when we look here, 720 is right there. Now remember, a bell curve is telling us the percentage of area covered. So we want to figure out how much this area is. of the bell curve? Well, I'm going to do a z-score. I'm going to say, okay, 720 is what I'm looking at, minus 560 divided by 75. All right, let me get my calculator out here. 720 minus 560, I didn't really need a calculator to do that, divided by 75 equals 2.1333 repeating. All right, now you, with your lovely calculators, you really didn't need to know that z-score, but I'm going to show you how your calculator can work both ways. So we know we're going to go into distribution. We're going to go down to normal CDF. And we can look at it this way. We can say we have a lower bound of 720. We have an upper bound of, I don't know, because we want to look above 720, so I'm going to put a very large number in there. Our average was 560. And our standard deviation was 75. So the area, if I turn it into a percent, move that decimal over 1, 2, is 1.6%, let's say. We didn't say where to round. Oh, it did say, it said round to the nearest tenth. Woohoo! So the probability that somebody scored above a 720 on this test is 1.6%. Now, back in my day when I was in school and we didn't have a calculator, we would have to use our z-table. So let me go get a z-table. There is my z-table. And I would come and I would look for 2.13. So notice I come down here, and this is the row of 2.1. And now since it was 2.13, I go over to the 0.3 column, 0.03 column. If you see up here, it's 0.01, 0.02, 0.03. So that's this column right here. So this is the number, 0.4834. Now, 4834, now let's go down and see what kind of z-table I'm looking at. Oh, I'm giving the area that's from the middle to my z-score. So that's 4834. So this is what I'm doing. Let me erase this and show you. The z-score gave me the area from here to there, because that's about where my score was. It gave me this area. And it told me that area there was 0.4834. It didn't give me this area, but this area is easy. This area is 0.5. So if I add that up, I get 0.9834. That's the area below my z-score. That rhymed. So if I do 1 minus 0.9834, because that will give me this area I'm looking here, because the bell curve adds up to 100%. So I kind of did it backwards. I get 0.166. Oh my goodness. And if I move the decimal over twice, I get 1.66%. Now you say I'm off, and that is true because if I go back here, 2.133, now I really would have done something called interpolation to figure out exactly, because I did 2.13 and there's an extra 0.3. So my percentage is really a number somewhere between 0.4834 and 0.4838. It's somewhere in between here. You don't have to know that because you have your calculator. Lucky ducks. So I'm just showing you how I had to do it when I was in school. Back to your calculator. You can also do this distribution using z-scores. So right now I have in my mean of 560 and my standard deviation. Well, I can do it with the z-score. In other words, I can say my z-score is 2.1333333. My upper is still an obnoxiously high z-score, but now my average is 0 and my standard deviation is 1. Get it? And boom, boom, boom. Oh my God, I get the same answer. So now most kids always like to use the average and the standard deviation because they're given, but you don't have to. You can do it by z-score. All right, find the probability that a completed test picked at random would have a score less than 500. So 500 is somewhere in here. So that's below average. So what I'm trying to do is I'm trying to find the area under the bell curve right here. Well, just because we're doing z-scores today, I'm going to do it by z-scores. 500 minus 560 divided by my 75. Come on, there we go. Equals, so that's negative 60 over 75. And negative 60 divided by 75 is negative 0.8. So I can come into my calculator. All right, so I'm going to do this by z-score. I'm going to go in here. My lower is a really small number because I'm looking for my area below. Negative 1. See how the calculator already put that in? I'm going to leave that. My upper is negative 0.8. My average is 0. My standard deviation is 1 because we're doing z-scores, and that's what z-scores are based on. It's based on the average of 0. And it is 2.1%. Sorry, 21.2%. So the area from 500 and below is 21.2%. And again, this is the same thing as yesterday. I'm just going to finish out this page very quickly. Find the probability that a completed test picked at random would have a score between 500 and 600. Well, 500 again is somewhere there. 600 is somewhere there. And I'm trying to find this area in between. What percentage probability of that area is covered by the bell curve? All right, and I'm just going to come back over here, and I'm going to go into distribution, number 2. And this one I'm going to do by the old-fashioned way, just to show you. I have a low of 500. I had a high of 600. My average was, brain of a goldfish, 560. And my standard deviation is 75. And that answer is 49.1%. Once again, if I had done standard deviation using z-scores, we just found out from the one above that a z-score that relates to 500 is negative 0.8. If I wanted to find the z-score that relates to 600, I have to say, okay, 600 minus 560 divided by 3.2. 3.2, that's from the last one, divided by 75 is 40 over 75, which gets me 0.533 repeating. So if I were to do that on the calculator, if I were to go into my distribution and to use it by z-scores and not by actual scores, my lower z-score is a negative 0.8. My upper z-score was 0.533333. That's enough. My average is always 0. My standard deviation is always 1. Voila, voila. Same number. Think you guys get how to do this. Enjoy your video. Bye.